Today we're going to be talking about securing web apps in Kubernetes with Spring Authorization Server. Ultimately, in a nutshell, we're going to show how to integrate Spring Authorization Server with Kubernetes and an OAuth2 client. Quick disclaimer, you can read this later. I'm just going to buzz over it. My name is Joe Grandja. I'm on the Spring Security team. My whole focus was on OAuth2 for the last 8 years, I think it's been. It's been a fun ride, no doubt, rewriting this OAuth2 story. Started with OAuth2 Client and Spring Security 5, Resource Server in 5.1, and then Spring Authorization Server just over 3 years. Went major with our 1.0 last November. So, you know, full circle with the OAuth2 story. My co-presenter, Daniel, here.
Hi everyone, I'm Daniel. I work in the Tanzu Application Platform group, and I work on the AppSSO component, where we provide SSO capabilities for developer workloads using Spring Authorization Server. I contributed to Spring Authorization Server when the project was getting started a couple of years back, and so we're here to present that together. Before we get into the technical details of the presentation, I kind of want to gauge the audience. Who here is familiar with OAuth2 and OpenID? Could you please raise your hands? Oh, that's almost everyone. And who is familiar with the Spring Authorization Server project? That's quite a few hands, but not that many. Okay. And completely different topic. Who's familiar with Kubernetes, like the basics, deployment services, resources? Half the audience. So we have an OAuth crowd here with us today.
Right on. Well, thanks for answering that. Just so we have a gauge of the audience. So this is the agenda. It's going to be kind of two parts. I'm going to do the first part. We're going to do a demo, pick the major use case, key rotation, right? We're going to do a very simple demo to start with, just in-memory implementation of key rotation, and then the Kubernetes way. And then Daniel is going to present on...
So the demo is a demo example, and then we're going to show you a real use case of using Spring Authorization Server to build a completely custom experience, Kubernetes native experience of providing SSO capabilities with AppSSO. So we'll introduce the concepts of AppSSO, and then we'll show you how to use it in its most basic form to obtain a token, and then in its full story of, I'm a developer, I have some code, how do I add SSO to it with this when it's running on the Tanzu Application Platform?
Right on. So let's just jump into it. We're going to basically do a demo on how to integrate Spring Authorization Server and Kubernetes. We got a very, very basic demo here. Ultimately, the use case is key rotation, right? So we want to be able to, demo a use case where we have a key, it's signed an access token or ID token. In this case, we're going to perform an OpenID Connect flow. So we got the SSO client or the OAuth2 client performing OpenID Connect. An ID token comes back on that flow. That ID token is a JWT. It's signed. So we're going to demonstrate that demo, and then we're going to do a key rotation, and we're going to do another OpenID Connect login to see that the new active key is being used, right? So very basic application setup to demo the key rotation. So to get this working in Kubernetes, right? So we have two applications, the authorization server application and an OAuth2 client application, right? We have a deployment YAML configuration. In that YAML configuration, we have a service and an ingress, right? So the service, we need to be able to access the authorization server or the SSO client externally, right? Using HP or HPS. So this is where the service configuration comes in. The ingress is, basically it's a routing rule that the ingress controller, we're using Nginx here, it basically consumes this ingress routing rule, and it ultimately says, okay, when a request comes into AuthServer 127 and so forth, route it to this service, right, the externally exposable service, and then route it to the application running in the pod, right? So that's our setup. We're using Kind. This is a really, really nifty tool here. Let's open up a new window here. And then here we have Kind. So Kind stands for Kubernetes in Docker. If you haven't used this, this is excellent for testing local development. Ultimately allows you to run a Kubernetes cluster locally within your environment in a Docker node, right? It's one node, right? So we have two applications, or two pods running in the one Docker node. So this is what we're using locally.
Maybe do you want to show
Yeah,
the
let's run through the application just so you can see how it looks like. So I'm gonna perform an OpenID Connect login here. All right, and we just have this basic landing page that displays the GWS headers and the claims of the ID token. Let's zoom this in so you can see that.
Oh, maybe with Command Plus.
Oops.
It's a trap. It's my laptop.
Yeah. Is this?
I do Command Plus maybe.
Command Plus. Okay.
Way. There you go.
Yeah. So the main things to look at here is the KID claim, so the key identifier, right? So by default we have this key installed at startup, and then there's the algorithm. I mean, there's nothing really. The main thing we want to demonstrate is the key rotation. So we have the KID here. So let's and we could take a look at the raw ID token here in JWT. Here we have the default KID, right? Now let's go to we've set up an admin page here in the authorization server application, and key rotation can be done in different ways, right? We could have an admin page like I got set up over here, got to generate key. Things could be automated using GitHops. There's many different ways, right? So just to demonstrate a very simple flow here of key rotation, I'm just going to press that generate key, right? And then we're going to go through the OpenID Connect flow and ensure that the new key, the new active key, is being used to sign, okay? So let's generate that. So we have a new key here. Now let's go through the OpenID Connect flow. I'm going to log out. I'm going to log back in, and there you go, right? It's using the new key, right? So how did I implement this? Using Spring Authorization Server. Let's take a look at it. We have this, let's go back to the,
PowerPoint.
Oh yeah, there it is. Okay, so the way we've implemented is we have a key repository abstraction. So we have basically two implementations. We have an in-memory one and a Kubernetes one. Let's talk about the in-memory one first. And we'll look at this implementation. So the in-memory, basic CRUD. We got find, get, delete, save, right? It's a repository of keys, key objects. We have a key here. Right? Two of the common attributes is the ID, the KID identifier, the created date, and a couple of subclasses, right? Symmetric key that stores a secret key, and then asymmetric key for the public-private key pair. Now, the implementation here in memory, it's pretty basic, right? It's just storing the keys in memory, right? Now, we're making the assumption here that the implementation on get keys, it returns the list of keys sorted by created date, right? And we're basically assuming that the first key is the active key. Now, I could have implemented this differently. I could have added a, active attribute on the key object, but we're just keeping it simple. So we're assuming the first key is the active key. Okay, and then. So this is the main repository, and this is being used in a couple of spots, right? This key repository. Go to security configuration. So the JWK source here, so this Spring Authorization Server requires this component, right? This is the component that's used to obtain the JWK that's used to sign the ID token or the access token, okay? And then the OAuth2 token customizer here, we're configuring this. This is also being used here. We want to be able to select the active key. As I mentioned earlier, the key repository returns a list of keys. The first key, we're making the assumption it's the active key. So here we have, I'm looking up the keys, getting the first key, and then I'm setting the GWS header KID claim to the KID identifier, right? So that way, when the JWK source is being called by Spring Authorization Server, it selects it by the KID, right? The active key. So that's where the two components are used for key repository. So now let's go, let's jump into the Kubernetes key repository, okay? And how do we do this in Kubernetes right now? So I'm going to make a quick change here before Daniel talks about a little bit about the Kubernetes implementation. I'm going to make a change here, and we have Tilt running. Tilt is basically a CI tool. It's going to automatically build this, create the Docker image, deploy it, right? And we're going to just jump into the Kubernetes key repository here. And Daniel, would you like to talk about how we implemented this?
Yeah, sure. So this is the implementation of, instead of using a database or an in-memory list of keys, here we will leverage Kubernetes to give us the keys. The idea is that, as Joe has shown on the presentation, you will store your keys in a secret. Maybe you're doing GitOps. Maybe you have an external secret operator that copies stuff from whatever secret store you use, and your authorization server is picking up the secrets in its own namespace. And so to do that, we use the Kubernetes API client, the Java version of it, and we create what is called an informer, which listens for new secrets that are created. So here we are listening for secrets, and we want these secrets to have the type that we define, AuthServer JWK. So this beautiful API with 15 null parameters is inspired by the Go API. So basically, all the work they have done for the Kubernetes API in Go was ported in Java. It's not very Java-friendly when you read it, but it does exactly the same thing. It listens for changes. It gets notified. When you get notified, you have a little message that tells you, hey, I discovered a new secret, or a secret was deleted. And then in the end, it goes into this, this informer, and then you can, from the informer, you can pull the keys and say, list them, right? Give me the list of keys.
Nice, yeah. And the one thing that Daniel mentioned here, I'm taking note of here, is the type here, AuthServer JWK, right? This is actually used as a filter, right, when we're looking for keys in the Kubernetes cluster to filter out, these are the keys that I want based on this criteria that the auth server is going to consume and use, right? So let's take a look at, how do we go about doing key rotation in Kubernetes, right? We've got a couple of scripts here.
Before we run them, do you want to show the app running?
Yeah, let's do that. Yeah, make sure we just see the one there. So let's go back to the auth server admin page. We're going to do a quick refresh here. We'll log in.
So we log in because the app was rebuilt, redeployed, or session was destroyed.
And there we're at, right? So that's the default key that's stored in our Kubernetes cluster when things start up. Now I'm going to perform key rotation, right? We want to get another key in our Kubernetes cluster, and ultimately we're going to see two keys there. We're going to have a new active key. So how do we go about doing that? We got a script that does that, but like Daniel said, this could be automated, right? Using GitHops. I mean, there could be many different ways of doing it. Ultimately, we want to get that key in the Kubernetes cluster. That's the ultimate goal. However we get it there, we're going to keep things simple here. We basically have a couple of scripts. So I'm going to run this first script here, generate key. We'll take a look at a couple of things here. As you can see here, it's a secret. There's the ID, signing key 2020. It's an RSA PEM encoded key. And there's the type, right? AuthServer JWK, right? That's ultimately that filter that's being used by that Kubernetes key repository to, get me all the keys filtered with AuthServer JWK, all right? So I just generated a key. It's not in the Kubernetes cluster right now. Right now, what we're going to do is I'm going to run this other script here. Apply new key.
Which is basically calling the generate and then applying it to the cluster. I think it's at the bottom, right?
And there it is, created, right? And now I'm going to go back to my admin page. I'll do a quick refresh. Okay, so I see two keys there, right? Now it's being consumed from the Kubernetes cluster. Now I'm going to perform an OpenID Connect flow. I'm going to expect the signing key ID, to be used, right, during the OpenID Connect flow. So let's log out here, log back in, and there you have it, right? So now it's using the new active key. And that's pretty much my end of it. I'm going to hand it over to Daniel, and he's going to talk about AppSSO.
Thanks. Thanks, Joe. So this is a demonstration of using Spring Authorization Server to customize the experience you want to provide your users with. So now we're reading from Kubernetes. And this is exactly what we did on the AppSSO team. So AppSSO is a component that runs on the Tanzu Application Platform. And it allows developers to add SSO to their app, mostly by requesting credentials and having those credentials in the app. And you don't request the credentials by sending an email to your identity team and then waiting for your credentials back. And here, the idea is more self-service. And how do you do this? The Tanzu Application Platform is a Kubernetes-based platform. So the API to this component is Kubernetes resources. So we're going to be writing some YAML. So the main bit of YAML that is managed by this component is an auth server. This is not a developer concern, it's more of a service operator. So the identity team will be writing this piece of YAML to describe how their auth server will issue tokens, what the tokens will look like, where the users are stored, and so on. On the client side, to build and expose the client that Joe showed, we would be using a workload resource. So the workload resource is not a SSO-specific resource. It's a tap resource that says, basically the important bit is that it points at a Git repository. Then the Tanzu Application Platform will pull this repository. It will build an image with this. It will perform, security, vulnerability scanning. It will apply defaults. It will configure. And then in the end, once the whole supply chain has completed its work, it gives me a URL and my app is running and I can click on it and I can go see it. If I want to add SSO to it, if I want to connect it to AppSSO, what I will add to this workload is a service claim here. So the service claim is the way for the workload to say, I need a database, I need an SSO, set of SSO credentials. So here we say we want to claim an SSO, set of SSO credentials. And what does this reference? This ultimately references a thing called a client registration. The client registration, you can think about it as going into your Okta console or your Azure AD portal, and you go and you click and you say, oh, I want a new app, and it's going to be called SSO client, and it's going to have this redirect URI, and I want to make these scopes available, and I want to make this grant type, and so on. You would describe it here in the client registration YAML. And all of these are tied together loosely by name, basically. The client registration references the auth server in case you have multiple auth servers running on your platform. You're going to say, well, this client needs tokens from that auth server. And then the workload claims the client registration, says, I am going to be using the client ID and client secret that are issued for this client registration. So we have a demo for this. It runs on a tap sandbox. I'll give you a link after that. Here we go. I'm going to stop the current demo, and I'm going to switch to a tap cluster. All right. And I'm going to deploy everything right now. Ooh, it's in tap. Maybe go here. OT, deploy auth server, and then we'll look at the details once this is deployed. Why am I doing this? Is because we're building a workload. So it means it's going to pull the code, it's going to build the image, it's going to build the Java artifact, build the image, and so on. So it takes a little while. And then I'm going to deploy the workload. I'm using Cap, which is a nicer version of kubectl. And I'm going to say, I'm going to deploy an app, I'm going to call it workload default, and then I pass it the YAMLs I want in this Cap app. So I'm going to deploy those, and then it will get built as we look at the resources and the details. So we mentioned the first bit is the auth server, that describes the things that runs and issues tokens. So it's an auth server here. It has the default Kubernetes manifest type of things. If you want labels, where in which namespace, and so on. And then it has its own capabilities. One of them is basically what Joe showed you in the first part of the demo. Key rotation or key selection. Maybe a key gets leaked, I need to invalidate it, or like every week I rotate my keys. So instead of having the operators need to know that you need a certain type of secret, what they do is in their AuthServer definition, they say, oh, the active key is this one. It's a secret called sample token signing key. And then the passive keys are these two, right? The second important bit is the identity providers. AppSSO is not in the business of managing users. This is delegated to your your corporate SSO, your corporate LDAP or your company Azure AD or Okta or whatever. So in here, we're using Azure because we have access to Azure AD here at VMware. And so we say upstream, my users are going to be in Azure AD, and I'm going to be using this client ID and this client secret for Azure. I'm going to be requesting the OpenID email and profile scopes. And then we're going to customize a little bit the tokens that we issue. So in the ID token, I want an email claim, and I want the value to come from the unique claim from Azure, because this is how it's set up. And I want a roles claim, and that roles claim will come from groups. In Azure, there's a groups, and then an ID of a groups. And I'm part of quite a few groups, so I'm filtering them down. And I'm keeping only those that have France in the name, because I'm a French employee, so I am part of a few groups that have France inside. And there are many, many other things you can do here. So, you can decide where your sessions are stored, what the expiration times are for your tokens, what TLS, how do you want to provision TLS for your auth server and so on. But we're not here to show the full API of this. If you want to discuss it after the presentation, it'd be a pleasure. So this is applied to the clusters. So now with kubectl, I'm just going to use K for short, and I'm going to get auth server in the demo namespace. And we have one auth server that's been provisioned, and it has one client, which I provisioned for my workload, and it has a URL here, the HTTP auth server, this one. So the auth server being an OpenID identity provider, I can call the well-known, if I can type, OpenID configuration endpoint, right, which is a standard OpenID endpoint where you get the details about the auth server, like which algorithms are used to sign tokens and so on, right? So this is running on my platform. Now, how do we use it? We need credentials. And so to provide credentials, we use a thing called a client registration. So the client registration, you will notice, maps very nicely to what we have in Spring Authorization Server. Maybe you want to add a word on that?
One of the other core components, just like I was mentioning earlier, the JWK source is a source for keys. We also need a source for the registered clients, right? That's the registered client repository. We provide a couple of implementations out of the core framework, but in this case, this is a perfect candidate to integrate also with Kubernetes. Just like the Kubernetes key repository looks up the secret key resources from the Kubernetes cluster, it'd be a similar implementation, right? We would look up the client registration resources in the Kubernetes cluster and ultimately provide the registered clients with this custom registered client repository.
Yep. Yeah, exactly. So the registered client is very similar to what you would see in the Java bit, right? You have a set of strings, which is redirect URIs. Here we have an array of strings, which is the redirect. So they map nicely. So we can apply this. So again, cap deploy. I'm going to call it client reg. Why not? And the file is client registration. So I apply this. Okay. And then I can look at my auth server again. This one. And let me put it on top. This one now has two clients, right? Because I added a new client through that client registration. I can describe it. Describe the client registration in the demo namespace, and it's called demo client. And so this gives me the spec that I applied, but it also gives me in the status, it gives me some things as a developer, it could be interesting to me. So for example, which auth server is targeted by this client? Which auth server is going to give me ID tokens? It also gives me a help message here. It tells me, find your client secret by running this kubectl command. So we're going to do just that. So I'm going to select it and run it. So it's a Kubernetes secret, and I can get the data out of it. So tell me I want YAML. So a Kubernetes secret looks like this. It has a few keys, and they're base64 encoded. So I'm going to grab these and decode them. So here we use the YQ tool, which is kind of like JQ, but for YAML. And we base64 decode all of the keys, and so I can see the contents. And here, this is what, as a developer, I can put in my app. And then, most importantly, I have a client ID and a client secret, which I can use to obtain a token. So I have a script here to grab those and put them in my environment. So grab the key, grab the client ID, client secret. I'm going to take that, paste, cool. And so now I can request a token. So I call the issuer URI / OAuth2 token, OAuth2 token, which is the token endpoint, with the grant type client credentials, because that's the easy grant type for demos. And I need to be authenticated. I need to pass an authorization header. So I'm passing client ID : client secret. So that's default OAuth2 behavior, right? You have your credentials, you pass them. And there I go, and I obtain an access token, because this is client credentials, so there's no ID token. So I could go and look at the details, but that's not what's important here. What's important is we got a client ID, we got a client secret, and we can exchange them for a token. But then, having that usable by my Kubernetes thing, my Kubernetes workload, it's not straightforward. What do? Do I have to go and copy the values and put them in environment variables, or do I mount the secret? So it's not very developer friendly yet. So what we do here is, with the Tanzu Application Platform, the operator will take the auth server they created and expose it in a special way with this special resource. As a developer, you don't really see it. What's important is that it says, I'm going to provide capabilities, and I'm going to call it AppSSO server. And as a developer, you do Tanzu services classes list, and you see all the services you can add in your app. So one of the service, for example, you can have a Postgres database. You can have a Redis server. And you can have the SSO server that we added. So through this, developers can request access to credentials. How do they do it? Rather than using directly a client registration, they will use a class claim, which is a slightly higher level of abstraction. And they reference this. They don't need to know anything about the specific auth server resource. They don't need to know that there are labels or whatever. They just say, I want an SSO server, or I want a Postgres database. And you'll recognize the values that are in the client registration. So like, which scopes are going to be, which scopes is this client allowed to request, or which grant types is this client allowed to use. The slight difference here is that we're just using redirect for building the redirect URIs. We build them for the developers. So we template in the workload URI, if you will, here. You don't have to paste it. You don't have to know where your workload runs. Just know that you're going to deploy a workload called SSO client, and then we'll put the URI here for you, so that when you deploy in different environments, you don't have to create different resources, right? Maybe in staging, this is apps.staging.example.com, but then when you go to prod, it's a different URI, so it would be a different class claim. We just do that for you. You just say which path, similar to the base URI that is available in Spring Security for templating the redirect URIs. And so this class claim is then bound to a workload. So the workload, as we said, is a tap concept. It references a Git repository. So here we're going to target this Spring Auth server case repository. It's going to pull the image. We'll give you the URL at the end of the talk. And it's going to say, we want the client path, or which directory are we pulling the code from? So we're pulling from SSO client here. It's going to go build this Java Spring Boot app, and then it's going to make an image and so on. And we say we want to claim that SSO client. I want the credentials that are created for that SSO client. I want them in my app. And through Spring Cloud Bindings and Spring Boot, this is made available automatically in my app. Maybe you want to say a word about
Yeah, for
that?
sure. Yeah, during this service binding process where the client application is requesting to bind to the SSO server, it uses a combination of the claims in the service claims as a template, the scopes, the redirect URI, and so forth. And the SSO service or the binding process generates the client ID, client secret. It's stored in a secret resource in the Kubernetes cluster. And then ultimately, those values are transformed or translated to the Spring Boot specific properties, right? Spring Security OAuth2 client, and the client registration, all the metadata associated with that. Loads it into the environment, into the Spring Boot environment, and then auto configuration kicks in. That's how it works.
So in our SSO client, we have nothing that is Kubernetes specific. Our SSO client, you can run it on your local machine. We run it on Tilt by having a special profile that has all the properties that Joe mentioned, right? But when you run it on tap, we don't have anything. It's through the binding, through like reading that secret, and then it creates all these properties for you, and then Spring Boot does the auto configuration. Okay, cool. So this is built now. It should have been it should have enough time to build it. So I'm going to open the GUI for the Tanzu Application Platform. All right, open it, please. There we go. And so in here, I would go to supply chain workloads, and I get my SSO client. Maybe zoom in a little bit more. And in here, I have a graphical representation of what the platform did. So it downloaded the source code, then it built the image, then it configured it, then it applies conventions, and it registers the endpoint, and so on, and all the way till the end, which is it delivers the app to the platform with this delivery step that goes green. And in the end, I get a URL. So I'm going to copy that one here, go to a private window. Yes, that one. So you notice here we're targeting the client, right? So if we navigate to it, then we get redirected to the auth server on my tap cluster. I can log in, and I'm going to log in using Azure. Okay, use my corporate account. So this logs me in using my company's SSO system. Then I get logged into the auth server, and then I get logged into the client in the end. But before I get logged into the client is requesting a token, and it asks the client, or SSO client asks for the email profile and roles scopes. So as an end user, I approve. I say, yes, I will give access to my email to the SSO client. So I approve this, and I get redirected back to the client with a token. And this time it's a real token. It has my real name in it. It has my email. It comes from an auth server that is available on the internet, and it has the roles. As you remember that we said, I'm going to show the roles that contain the word France in them. So point hebdo France staff with a French accent, and the token as you see. All right. So this is the experience of using the Spring Auth server without knowing that there's a Spring Auth server behind that. So as I said, this is running on the Tanzu Developer Sandbox. This is it's available as of this conference. You can go there, you can request a Tanzu Application Platform cluster and start deploying your apps to that. It's a small triad cluster. It has a guide on how you can deploy your apps. I'm gonna let you take pictures. Everyone all right? Cool. I think that's it, right?
Yeah, let's do, we've got a couple of talks coming up too. There's, Rob and I are actually doing a security roundtable tomorrow and Thursday. Come check us out, ask questions, love to answer them. And there's a couple of talks here, Josh and Marcus, Wednesday, 4 p.m. on SAML, and then Josh and Steve are doing a workshop on OAuth2 step-by-step, like just full deep dive workshop, so come check that out too. Thank you very much. We'll open the floor to questions if anyone has any.
This is the repo that we showed, so you can go grab it. You can run. There are instructions for running the Joe's demo in a client cluster, provisioning a client cluster, running on it. There's a tap sandbox directory with detailed instructions on running it on tap sandbox, although it's going to be slightly smaller because you have less permissions. And yeah, we have
very much.
The timer says 16 minutes, but I think we have 5 minutes for questions. So, if you have any questions. And that's a feedback form. It takes 2 seconds, and it gives us great feedback to improve the talk as well.
Any questions, anybody? Go for it.
Yes, correct. So the question is there a shortcut to deploy everything and see it? Yes, that's correct. There's that in the repository. We could look at it, but in the Tap Sandbox one, you don't get to provision AuthServers because it's a more advanced capabilities. The Tap Sandbox that is publicly accessible is mostly for workloads. There's a shortcut that shows you how to do this if you have access to a full Tap cluster. If you don't, when we do services classes list here, there's this auth server that we provision, and I didn't mention this one, but in a Tap Sandbox, you have an auth server that is already provisioned with a user called user and a password called password, so you can integrate with it.
Are there any other questions?
You know, it takes a little time to brew, but if you have more questions that come up during the conference, find us in the hallway. We'll be at the booth tomorrow around 12.
Yes, 12 to 2.
Pleasure.
Great, thank you very much. Thanks for coming out.